All right, welcome. Today, we're going to pop the hood on one of the most powerful operating systems out there. We're digging into the core concepts of how Linux actually works. Yeah, we're skipping all the fancy desktop stuff to get a look at the real engine underneath.
And that, right there, is the perfect way to think about what we're doing today. Forget the shiny exterior for a minute. We're here to get a feel for what's really happening deep inside the machine. So where do we even begin with all this? Well, we start at the absolute foundation, the Linux file system. And it's all built on this one central idea that honestly sounds a little weird at first, but you'll see just how powerful it is. This is where the real genius is. Instead of having one set of rules for your documents, another for your hardware, and a third for network connections, Linux just represents them all as if they were simple files. This creates one single consistent way to manage pretty much everything. So here's a look at the map of that system, the basic layout. It all starts at the very top, at the root, which is just that single slash. From there, it branches out like a tree. You've got /bin, which holds your essential commands, /etc is where all the system-wide settings live, and /home is, well, it's your personal space. And remember that everything is a file idea? Check out /dev. That's where your actual hardware, like your mouse or hard drive, literally shows up as a file you can interact with. Okay, and this brings us to a really, really important warning. When you're editing those critical configuration files in /etc, you should never, ever use a word processor like Microsoft Word. Why? Because it'll sneak in all this hidden formatting code that can just completely wreck your system. You have to use a plain text editor, something like Vi, Nano, or Gedit. Now, let's dig a little deeper here. It's not just about how much space your files take up. See, every single file also has something called an inode. Think of it like a library card for the file. It stores all the metadata, like who owns it, what the permissions are, and where the actual data is stored. But here's the catch. You only have a fixed number of these inodes. Now look, it's pretty rare, but it's technically possible to run out of them by creating millions of tiny empty files, even if you still have tons of disk space left.
All right, so we've covered the static blueprint of the system. Let's move on to the living, breathing part of it all, the processes that are actually running.
Think about it. Every single time you run a command or open an app, you're creating a process. And since Linux is built to handle multiple users and multiple tasks all at once, it's constantly juggling hundreds, sometimes thousands, of these processes at the same time. So how does it keep all this straight? Well, it uses a few key IDs. Every process gets its own unique PID. But the really critical ones for security are RUID and EUID. The real user ID is simply you, the person who actually started the program. The effective user ID, though, that's what determines the permissions the program is running with right now. And this right here, this is a cornerstone of Linux security. It makes sure a program can't just go off and do things that you yourself aren't allowed to do. So how do you actually peek under the hood and see what's running? You've got two main tools for the job. The PS command is like taking a quick snapshot. It shows you exactly what was running at that one moment in time. But top is like a live dashboard. It's constantly refreshing, showing you in real time what's eating up your CPU and memory. It is the perfect tool for figuring out why your system is suddenly so slow.
And speaking of slow, if you're ever looking at top and you see that swap number climbing high, that's your system basically screaming for help. It means you've run out of physical RAM and the system is now using your hard drive as overflow memory. And because a hard drive is just way, way slower than RAM, heavy swapping will make your whole system feel like it's crawling through mud. So what happens when an app just freezes up on you? Well, the kill command is your friend, but there's a right way to do it. First, you ask nicely. You use kill with the process ID. That sends a polite signal, technically called sigterm, asking it to please shut down. If that doesn't work, well, then you bring out the big gun, kill -9. That sends the sig kill signal, and trust me, a process cannot ignore that one. The system just ends it right then and there. Okay, so we've got the map, which is the file system, and we've got the engine's moving parts, the processes. Now for the last piece of the puzzle, the cockpit. This is where you get in the driver's seat and take direct control using the command shell. Even with all the slick graphical desktops we have today, the command line, or the shell, is still where the real power is. I love how the source material puts it. It's essential if you really want to meddle with the heart of the system, automate your work, and truly get what's going on. And getting started is easier than you think. It really just takes a handful of these bread and butter commands. You've got ls to list files, cd to change directories,
and PWD to see where you are. Then CP, MV, and RM to copy, move, and remove files. That's pretty much the foundation of getting around.
But I've got to stop right here and just hammer this point home, just like the source does. You need to be definitely careful with RM. There is no trash can. There is no undo button on the command line. When you use RM to delete something, it is just gone. Forever.
Okay, so what if you lose a file? You've got two great tools. Find is the slow but steady detective. It searches the live file system, so it's always up to date and you can give it super specific criteria. Locate, on the other hand, is lightning fast. It searches a pre-built database. The only trade-off is that it might not know about a file you created, 5 seconds ago. Look, are you feeling a little overwhelmed by all these commands? Let me give you the single most important command you will ever learn. Seriously, it's man. It stands for manual. If you ever forget how a command works or what its options are, just type man and then the name of the command, like man ls. And boom, the entire instruction manual pops up right in your terminal. And finally, let's wrap this section up with a huge pro tip from the source. When it comes to editing all those text files we talked about, learn the basics of VI or Vim. Why? Because no matter what Linux or Unix system you log into, a tiny server, a massive supercomputer, whatever, I guarantee you VI or Vim will be there waiting for you, even when there's no graphical interface in sight. All right, let's take a step back and pull all these pieces together. What we've seen is that the power of Linux really comes from these distinct layers working together. You have the foundation, that brilliantly simple idea that everything is a file. Then you have the activity, the secure, multitasking engine that juggles every single process. And finally, you have the control, the command shell that gives you direct, unfiltered access to all of it.
And that really brings us to the final and maybe most important question. Just think about it for a second. How does this simple, three-layered architecture allow Linux to be so unbelievably flexible? How can this same core design power a tiny little smartwatch, the router in your house, and the biggest supercomputers on the planet? That elegant power is what you're tapping into every time you open up a terminal.